So today we are going to go through 1.2 in our textbook, Geometry's 3 Undefined Terms. So we're going to start by asking, why do we study geometry? Why are we all here? Then we're going to talk about the language of geometry, right? There's a language of algebra that you guys speak. You know PEMDAS, you know what parentheses mean, right? And in geometry, there's a different language. We need to start talking about what that language is. And then we're going to talk about what are definitions in geometry. What does that mean? And then we're going to talk about, again, these 3 undefined terms. What's a point? What's a line? And then there are parts of a line. And finally, what's a plane? And then we're going to talk about something about dimensions. And then finally, postulates, which is a Greek word that you've probably never heard before, but you'll know what that means by the end of today. Okay, so why do we study geometry? Okay, geometry is important. It's all around us. Okay. If you create art, if you're playing sports, if you've ever done any construction work, right? If you've ever tried to paint a room, put stuff in a room, all those things require geometry, space, putting space within space, right? And so by having some formal way of doing it, we can help us solve those kinds of problems. Okay? And geometry has its own language. In order to learn and understand geometry, you must know the vocabulary and the notations. This will allow us to read, write, and speak the language of geometry, right? And I know you guys already speak, like I said, the language of algebra, right? If I put some expression up to a 5th grader with a bunch of parentheses and brackets and exponents, they wouldn't know what to do first. They don't know the language. You guys all do, PEMDAS and whatever else. You know the language, and so by the end of geometry, you're just going to know that language easy. Okay, so definitions, right? A definition is simply a statement of a meaning of a word. You all know that, right? It's what's in the dictionary. Okay? But most of the time, when we introduce a new term, we define it using terms we've already defined. Right? So if I say, what's a triangle? Hopefully someone could say, oh, a triangle is a shape with 3 sides. Okay, so we defined a triangle. Okay? But the trouble is, if I define a triangle and I say, okay, well, it's a shape with 3 sides, and I say, okay, what's a shape mean? What's a side mean? And you say, oh, okay, a shape is made up of a bunch of sides. Hey, what's a side? Okay, well, a side is, you can just, no matter how you go, I can just keep asking, what's that, what's that, what's that? Right? And you'll never get there. Right? Someone can always ask that. So the first definition can't work this way because there aren't any words to define it. Right? So, therefore, we have to have some undefined terms. Right? In geometry, we're going to have 3 of them: point, line, and plane. And what's great is that even though these can't be defined, because again, if you define them, you're going to have to use words to define them, and then someone can say, well, what do those words mean? And then what do those words mean? And what do those words mean? Okay, so we can't actually define them. What we do have to do is we have to describe the ideas in a language we all understand, right? So I could never ask you, hey, define a point for me. Define a line for me. I'll never ask you to do that because the answer is I can't. They're undefined. You can't define a point. But if I say, hey, describe what a point is for me, oh, that you can do. You can describe it and sort of come around, right? So that's what we're going to do right now. We're going to not define a point because it's undefinable. What we are going to do is we're going to describe what that point is. Okay? So a point is essentially the basic building block of geometry. It's an exact location. Right? So a point refers to a location. Okay. So for example, in algebra, you guys have done it before, it's an ordered pair, and we call it x comma y. So that little red dot over there represents a location of the intersection between, it looks like x is 2 and y is 2, to come up with a point 2, 2. Okay. And here's the part that's really hard to understand. Okay. A point is infinitely small. It can't be measured in any direction. It has no length, no width, no depth. It's infinitely small. Okay. So because it's infinitely small, you can't draw it. If you could draw it and see it, if you can see it by definition, it's there, and if it's there, it isn't a point. Because a point is infinitely tiny. Okay. What we can do to represent a point, we use a dot. Okay, so right there, so if I say, hey, is that a point? The real answer is, no, that red thing there isn't a point, it represents a point. Now we get lazy over time, we'll say, yeah, that's a point, but in reality, a point can't be seen. If you can see it, it isn't a point. Okay? And to label a point, this is that geometry. This is the geometry language I was talking about. To label a point, we use capital letters. So, for example, I could call this point L, point Q, whatever I want. As long as it's a capital letter, then in geometry, as soon as I see a capital letter, I know that's a point. So one way to try to think of it is, if you make a dot on your piece of paper, that sort of represents a point. But now imagine you sharpened your pencil and it got even sharper. Then you could draw a point. Okay. Then you could draw a point and it would be even smaller. Now imagine you could have an infinitely great pencil sharpener. It could sharpen your pencil so that it was infinitely tiny. Then that would actually make a point. The sharper and sharper you make your pencil, the smaller and smaller and smaller you get to the point. And eventually, if it was so small that it actually didn't exist, then that would be a point. Because again, a point is simply a location. It doesn't actually have any dimensions. Okay, so now we're going to go through again. This is what, if some of you have your notes, some of you don't. If you have your notes, you will see that point, you have something like this. And so here are the key things you need to know about a point. The number one, you need to use capital letters. Number two, that a point looks like a dot. And a point indicates a location. It has no sides. And then we're about to know that when you connect them together, you can make lines, segments, rays, angles, polygons. None of these words have any meanings for us yet because we haven't defined them yet, but we will soon. And then finally, it looks like that. You'll see that you have a dot that represents a point, and then I put a capital letter next to it, and that lets me know which point I'm talking about. So A versus B versus C. Okay, let me give you a minute so you can get that down in your notes. Key things: use a capital letter. Looks like a point looks like a dot, but it's actually an exact location. And use capital letters. Your notes can look however you want them to look. Again, as long as I want you to make sure you get this information, and hopefully you will print out your notes next time, and then they will look exactly like this. Make your life a lot easier. Okay, let me give you 30 more seconds to print this out. I'm sorry, to copy this, and then we'll move on to the next one. Okay. 10 more seconds. All right, let's go on here. Okay, so we said we had three undefined terms. The first one was a point. The next one is a line. Okay, so what I'd suggest is what you might want to do is just wait and look up here and look at what I'm doing, and then when I show you the notes, then you can copy them down. That might make your life easier, so you can see what's going on and then copy them all down the notes. But again, if you're the kind of person who likes to take notes as I'm talking, you can do whatever you want. I'm just gonna, just like the last one, you'll see actually the notes that you need to take. Okay, so what is a line? A line is straight, right? In geometry, there's no such thing as a curved line. That's a curve. It's not a line. Okay. A line is made up of infinitely many points. Right? It's just one point next to another, next to another, next to another, all in a straight line. That's what a line is. Okay. A line is one-dimensional. It has no length. It has length, but it has no thickness or width or no depth. And it extends forever in two directions. So the answer to every problem, how long is this line? The answer is the same, infinitely long. Right? Every line, by definition, you can't measure it because it's infinitely long. A line can't be drawn either because it only has one dimension. Just like you can't draw a point because a point is infinitely small. If you could see it, it's way too big. Right? The same thing is true with a line. It may have length, but it has no width, it has no depth. You can't actually draw a line. But to represent a line, we draw it with two arrows on the end, so like this. Okay? And the thing you'll notice the arrow on the left and the arrow on the right. Right? That lets me know it's a line because, again, it goes infinitely far in both directions. I couldn't actually draw it. My pen would run out of ink and I still wouldn't even be close. It goes infinitely long, so we just draw these arrows here to let us know which way it is. Okay? And you can label a line 3 different ways. With points, we label them with a capital letter. With lines, you can pick any 2 points on the line. So, for example, there's A, and there's B, and so we can call this line AB. You can also put the letters AB with a line over it. And again, notice that there's an arrow to my left and an arrow to my right. That's how I know it's a line, because it has those arrows saying it's going infinitely far in both directions. Or finally, you can use a scripted letter, which I know many of you probably don't use script very often, but that's what it is. So for example, you could call this line L, okay, but not a capital L. If I see a capital L, then I know that that's a point. If I see a scripted L, like this thing over here, then I know, oh, that's a line. And again, it could be line L, line M, line whatever, any letter you want. You just have to use a scripted case. Okay, so we're starting to learn the language of geometry. Points are capital letters. And then, because 2 points are in a line, I can use those 2 points to define a line. Just call it line AB, or a line with the 2 letters of the line over it, or that scripted letter. All right, so here are the notes that you're going to want to make sure you take here. Okay, a line, you use 2 capital letters of the point on the line, or you should also say here, or you can use a scripted letter. 2 points on the line, a scripted letter, or you could have, AB with a line over it. Okay. Lines are made up of points that are a straight path. Lines extend infinitely far in opposite directions, and they contain infinitely many points. And so again, you can label it. Here you go. Like I called it line AB, AB with a line over it, or you can use a scripted case letter. In this case, I used M, but again, you can use whatever letter you want. So points, if I take a group of points, they can either be what's called collinear or non-collinear. What's that mean? Okay, collinear just means points that are on the same line. So in this particular example here, P, Q, and R are collinear because they are on the same line. And again, what line is it? Well, I could call that line PQ, I could call that line QR, I could call that line PR. Any 2 points would work. Those are the same thing. So I would say that points P, Q, and R are collinear because they are all on line PR. And then if that's collinear, the non-collinear are points that are not on the same line. So for example, P, Q, and X in this example over here. There's no way to draw a line where P, Q, and X are on one line. There's no way to do it. It doesn't exist. Therefore, those points are non-collinear. Right? And if you look, the word line is right in the word linear, right? It has the word line right in it to help you remember what collinear means. It just means co-line. They share the same line. All right, see if people taking notes. Let me give you a minute to get all these down. I'll be in lunch next door. I have a late lunch next door at D16. What? Yeah, 7th grade lunch. I'll be right next door at D16, yeah. All right, anybody need more time? Okay, great. Let's move on here. Okay, so now we've done 2 of our 3 undefined terms. A point shows location, infinitely small, represented by a dot. A line made up of infinitely many points, it's straight. arrows on the sides to represent that it goes on forever. Okay, now we're going to talk about parts of a line. Okay, so the first one we're going to talk about is a ray. It's a part of a straight line that goes infinitely far, but only in one direction. It has an end spot, right? And so when I think of a ray, the easy way to remember it is like in science fiction, people have ray guns, right? And what is a ray gun? A ray gun has an end point called the gun, and then you shoot that gun, and it goes infinitely far. It's a laser or whatever it is. And it just goes forever in that one direction in a straight line. So that's what a ray is. It's got an end point, but then goes infinitely far in one direction. Okay? And again, you can't, just like a line, you can't measure a ray. It's infinitely far. How big is this ray? The answer is it's infinite miles long. Okay? But to represent a ray, we draw a line with one arrow on the end. So like this. And like a line, it can be labeled in one of three ways. You can call 2 points on the ray, so I can call point A and point B, but just make sure that that 1 point has to be on the end point. So I can just call it ray AB. I can use AB with the first letter of the endpoint. With the first letter of the endpoint, so A is my endpoint, and notice the arrow, right? The arrow is showing me that I'm going infinitely far in that one direction. Okay, and finally you can use a lowercase scripted letter, again like L or M or whatever. Okay, but again, the thing that people get wrong when they do this is when they label this AB, they might choose, there might be another point on here that isn't on the end point. That labeling array AB lets me know that A is the end point. A is sort of that gun in the ray gun where it starts, and then it goes infinitely far, goes through B, and then just keeps going. Oh, whoops. Okay, so, sorry, yeah.
So, if the arrows flip the other way, that means B is where the...
Excellent question. I hope you all heard that. So, if the arrow were flipped the other way, for this one, if instead of saying AB, well, the arrow wouldn't flip the other way, you'd flip it around and call it ray BA. Okay, so ray BA is the ray that starts at B and goes infinitely far the other way. Yeah. Excuse me? No, you wouldn't switch the arrow. You always have the arrow going from left to right, but you would just have whatever the end point is first. Excellent questions. Okay. So far we've talked about a line, and you can have a line goes infinitely far in both directions. A ray goes infinitely far in one. So now we're going to talk about a line segment. We'll get there. Don't worry, I'll be there. All right. So a line segment is part of a straight line that has two endpoints. Okay, and unlike a ray, unlike a line, you can actually measure it, right? I can say this line segment is 5 feet long or 3 inches long or whatever it is. You can't do that for a line. A line is always infinitely long. Okay, and to represent it, we draw a line with no arrows because it's not extending in any direction. So it looks like this. We know it's a line segment because it doesn't have arrows. 1 arrow would mean it was a ray, 2 arrows would mean it's a line, 0 arrows mean it is a line segment. Okay, and like a layer, we can label it a bunch of ways. You can call the endpoints a line segment. So there's A, there's B, so I can just call this line segment AB, or I can just call it segment AB. The other way to do it is just call it like that, AB with a line over it. Notice that there's no arrow on either side. And then finally, you can use a scripted letter like, again, L or M or whatever. Okay, so we put this all in notes for you here. Okay, a segment, the symbol looks like that with no line over it. A segment is part of a line that consists of 2 endpoints. And there's an example of a segment for us. There's segment AB. Okay, array is AB. We call that ray AB. It's got, we know that A is the endpoint because that's the first one it starts. Array is part of a line that consists of 1 endpoint, and all the points on the line are on one side of that endpoint. Right? There's nothing on one side. A only goes in one direction, not the other. And the example of that is it look like that. There is ray AB. Okay, we haven't talked about it yet, but opposite rays, if you look at this example here, I have two rays. I've got CA starting at C and A going that way. And to answer your question, notice that I call it over here, I call it CA. Again, the arrow is going the same direction, but C is my endpoint. And I've also got ray CB here. And A, B, and C are collinear. So opposite rays are two rays that share the same endpoint and form a line. So again, if I take CA and CB and put them together, I make line AB because it goes infinitely far in both directions. So opposite rays are two rays that together make a line and have the same endpoint. And then finally an angle, which you guys know what it is, but now we can formally define what an angle is. So here's an angle over here I drew, and you can call this a bunch of different ways. You can say here it's A, B, C. You could start here and just say no, it's C, B, A. You could just call it angle B, because angle B is what's called the vertex, which again we'll get to later. Or you can call it, in this case, angle 1, because it has angle 1 there. So any of those examples of what you could call it. You couldn't call it BCA, because then C, the middle letter has to always be the vertex. Think of it almost like going traveling. If I'm traveling from A to B, then C, that makes an angle. Okay, so an angle is made up of two rays with a common endpoint, and that common endpoint is called a vertex. Okay, you got a lot of stuff to write down, so let me give you a minute while you guys work on that. A lot of definitions you're going to want to get down for our language of geometry. Okay, let's see if we can finish this up in another minute. One more plug for the notes. The people who had printed out their notes earlier and have used them, they're all done with their notes at this point, because they had all the stuff in black that's on the board here. They already had it all written in. All they had to do was write in the stuff in red. All right, 15 more seconds. All right, let's keep going here. Okay, so now we've talked about, so far, we said there are three undefined terms. The first is a point, exact location. The next is a line made up of infinite number of points, goes forever in both directions. Then a line has different parts. It can have a ray or a line segment. And now we're going to go to our final and third undefined term, which is a plane. And no, not an airplane, a different kind of plane. A plane is a perfectly flat surface extending infinitely far in all directions. Okay, so the way I try to imagine it is, imagine if you had a plane of glass. It's actually called a plane, right? Or a pane of glass, excuse me. And it's so big you couldn't see the edges. Or imagine the desktop that's in front of you, but instead of being that big, it goes infinitely far everywhere on it. It's like a giant desktop. In fact, it's so big you can't see the ends of it. Like a line, it goes infinitely far. Okay. So the figure to the figure to the left over here suggests the infinite extent of a plane, that it goes on forever. Okay. Usually, however, if you want to show a plane, you just show the thing on the right. So that's sort of it's called a parallelogram. Okay. So a point has no length, no width, no depth. A line has length, but no width and no depth. And a plane has length and width, but no depth. So kind of like this whiteboard here is a plane, because I can't go through it. I can't stack stuff on top of it, but I can go, not infinitely far, but essentially I can go as far up and down, left and right as I want. I just can't get into it or out of it. So that's why it's a plane. All right, so what is a plane? We call it, so you can call it plane P with a capital letter, or plane ABC. If you can find 3 points in a plane, just like it takes 2 points to make a line, it takes 3 points to make a plane. So I can just call it plane ABC. And there's an example of what it looks like, right? You can see that points A, B, and C are in there, so we can call this plane P. Okay. And again, unlike a point, if I just say P, I'm going to assume P is a letter. Because the P is a letter, I'm going to assume it's a point. So if I have plane P, I need to call it actually plane P. I have to write the word out, plane P. Or I can just call it plane ABC, because again, points A, B, and C are in it. Okay, and a plane contains infinitely many lines. I'm sorry, I'll let you guys write that down first, and I'll go to the next one. All right, then when we did line, we talked about collinear and non-collinear, and so for plane, we're talking about planar or coplanar or non-coplanar. Okay, coplanar just means points that are on the same plane. So for example here, points A, B, C, and D are that like top of the box, top of that prism there, and so those are all in that same plane right there. Okay, but points A, B, C, and F, if I look at those are not coplanar. There is no way I can draw a plane or imagine trying to take a piece of paper or whatever and having it flat and having it go through all 4 of those points. A, B, C, and D, easy. I sort of just take my paper and put it on top of the box and boom, it's touching all 4 points. But A, B, C, and F, because F's in that back corner there, there's no way I can take something flat, take a plane, and have it go through all 4 of those points. So the first ones are coplanar, and the other ones are non-coplanar. Okay, let me give you a minute to write that down. Let's see if we can get it in 30 seconds here. All right, 15 more seconds. All right, let's keep going here. So just kind of as a review, talking about dimensions here. Okay, so you know what dimensions are. Our dimensions are, you got length, you got height, and you got depth. So imagine this is going like into the whiteboard here. Okay, so what do we call something that has 0 dimensions? It has no length, no width, no depth. What's it called? The terms that we just learned here, which one has no length, no width, no depth? It has 0 dimensions. A point. A point has 0 dimensions, no length, no width, no depth. Okay, what do we call a thing with one? A line, right? It's a line, or I guess also a ray also has only one, and a line segment has only one. But yeah, a line. What do you call something with two? It's a plane, right? It goes infinitely far in length, infinitely far in width, but it's got no depth. And then finally, 3, we haven't talked about it yet, but that's real life, that's space. Right? That's all these things, a point, line, and plane, they don't actually really exist in the world. You can't actually pick up a point. You can't hold a plane. Right? Even a piece of paper, which is kind of like a plane, it's still got thickness, right? If you take a book, it's made up of hundreds of pieces of paper, and you can see that it's got thickness, right? If a piece of paper were really a plane, then you could have a million pieces of paper, and you still would have zero thickness. All right, so finally, the final thing we need to go over in our notes is a postulate. Okay, what is a postulate? Sometimes you'll use the word postulate, sometimes they use the word axiom. I tend to use the word postulate, but they're interchangeable. And all a postulate is an accepted statement of fact. Right? Kind of like undefined terms. Undefined term, you can't define it. We just say, no, point exists. Define it for me. No, I can't define it for you. It's there it is. Okay? An axiom or a postulate is just something that we say, it's true. And if you said, Mr. Hayes, prove to me it's true, show me it's true, the answer is, I can't show you. You just got to believe it. Just look at it and see. Okay? But axioms and postulates are usually so obvious that no one would ever say, oh yeah, I don't believe that, right? They're really, really obvious. So, here's your first postulate. Okay, here's your first postulate, which says that through any 2 points, there is exactly one line. So you can see here that line T passes only through, line T is the only line that passes through points A and B. Okay. Now, a quick word, your textbook numbers every one of these postulates. This is 1-1, because it's the first postulate in chapter 1. These are actually the postulates. I think they're the same numbering system that Euclid used 3,000 years ago or 2,500 years ago. Okay, I will never, let me repeat that, I will never, ever, ever ask you to memorize what numbers they are. I will never, ever say, hey, remember postulate 3.7? Because the answer is, I don't remember it. I don't expect you to remember it. I would say, however, hey, remember there's a postulate that says that 2 points make up a line. Right? So you need to, I'm not saying you don't need to know this, you do need to know this, but I'll never ever refer to it as postulate 1.1. And if you refer to it as 1.1 to me, I'll be like, what's that again? Tell me what it means, because I just don't remember. Can't do that. Right? And so this first postulate you guys have used a lot before. Right? In algebra, when you are graphing a line, right? What do? You find one point, you find a second point, and you draw the line, because there's only one line that goes through those 2 points. If it was more than one, then you'd have to draw 3 lines, or 3 points, or 4 points, or 5. But luckily, when we're doing algebra problems, all we got to do is find 2 lines, put a ruler on it, and boom, draw that line, because we know there's only one line that goes through those 2 points. Okay? Now somebody said, hey, Mr. Hayes, prove that to me. The answer is, I can't prove it. It's a postulate. You just got to accept it as a statement of fact. And the postulate says, for any one line, there's only if 2 points make up a line, that for any one line, only one line, or for any 2 points, only one line goes through it. Okay. So hopefully, when you think about this and look at it, you're like, well, yeah, duh, of course that's true. And pretty much all the postulates of the axioms, you're going to look at them and be like, well, duh, yeah, that's true. Okay, but just like these non-defined terms, we start with basic stuff and then we build up for it. So the first postulate we know is that 2 points make up a line. Okay. The second one here is if 2 lines intersect, then they intersect at exactly 1 point. Okay. If 2 lines cross, they cross at 1 point. They're not crossing at 2, they're not going back and forth, not crossing at 0, right? And what does intersection mean? Intersection means a set of points that geometric figures have in common. So if you look at AE and you look at BD, what do they have in common? They have in common point C. They intersect at point C. Point C is the only point that's on both lines AE and BD. Okay. And again, I think if you think about that, hopefully you'd say, well, duh, of course that's true. If lines are straight, once they cross, they can't come back and cross again. If they did, they wouldn't be straight. Okay. And again, this is postulate 1.2, but I will never ask you that. I would just say, remember, two lines intersect at only one point. Okay. The third one is, let's see if we can figure it out. If the second one is two lines intersect at exactly one point, what does the intersection of two planes look like? If I imagine, this piece of paper here and this piece of paper here, and they intersect, what's that going to look like? Let's do a drawing of it right here. So if I've got these two planes, this purple plane here, which is plane, what is that plane? That is plane STW, the purple one, and plane RST right there, that green one. They intersect at a line, and the line in this case is ST. So if two planes intersect, that intersection is one line. If two lines intersect, that intersection is one point. If two planes intersect, they intersect at one line. And then we've got one more postulate. Postulate 1.4 is that through any three non-collinear points, there exists exactly one plane. So it's kind of like this first one here. Through any you need 2 points to make up a line. You need 3 points to make up a plane, but they can't be on the same line. So it takes 2 points to make a line, 3 points to make a plane, and that's why we call a plane, you call this plane down here, you call it RST, or the one I just drew up here is RSQ. Why? Because if I know those 3 points, that's all I need to know. Then I can define that plane. There's only one plane in the whole universe that goes through those 3 points. All right, so now, as part of your notes, I always give you some example problems as well, so ones you can look at and so just make sure you know what's going on. So let's look at the first one. Okay, there's a line there, QT. How else could I name QT? What's another way I can name QT? What? Okay, line QT. What else? But give me some other possibilities besides QT. Well, I'll do the first one because it might be hard to see. So QT, I could call it TQ. Right? Doesn't matter which order. QT, TQ is the same thing. I could call it QN. Right? Our first postulate says that 2 points make up a line. So if I pick any 2 points on this line, it's the same line. QT. So TQ, QN, NQ, QN. I could call it line M because it's down there. Those are all referring to this same line right here, the one that's going up and down. Okay, what are 2 other ways to name plane P? Well, how many points do I need to name a plane? 3. So we just pick 3 points. So for example, how about plane RQV? That would work. How about plane SVQ? That would work. Okay. But I couldn't choose RQS because those are on a line. And not only that plane, but any plane that goes through that line would work. So I have to pick 3 non-collinear points for my plane, and those are the examples. Okay. What are the names of 3 non-collinear points? There's a lot of options here. I just chose some examples here. So T, Q, and N, right? T, Q, and N are collinear points right there. They all make this line, T, Q, N. Or R, Q, and S, they make a line right there. Okay. What about the name of 4 coplanar points? Well, PQ, PQ, S, and V. All of those points are on plane P, so they are all coplanar. All right, let's look at our next example problem. What are the names of 3 segments in this figure? Somebody give me the name of one segment. What do you got? Yes, give me a name of a segment that's here. PQ is the name of a segment. Excellent. Who's got another one? QR. Excellent. So we got this one and we got this one. So the only one left is them together, which would be what? PR, right. So we got PQ, we got QR, and we got PR. That's it for the number of segments. Question? No? Okay. What are the names of rays in this figure? Well, we got PQ is a ray, right? I could start here and just go that way forever. QP could go there forever. PR, RP, QR, RQ, all of these are different rays that are shown here. Okay, but if I'm looking specifically for opposite rays, I only have 2. Right, the 2 opposite rays are what? Yeah, so QP here is a ray. Oh, it's the opposite. Yeah, so you're saying QP and QR, exactly right. Those are the opposite rays. One's going all this way to the left, one's going this way to the right. Together, those 2 opposite rays make line PR. Okay, the final thing we got to work on is a question on planes. So each surface represents a plane. What is the intersection of, and you got to learn how to, it's tough to do because right, we're looking at a 3-dimensional thing in 2 dimensions, so you got to sort of learn how to do this. So what is the intersection of ADC, so that looks like the top of the box there, and plane BFG, so that's like the side of the box there. So what's the intersection of the top of this box and the bottom of this, or the side of this box? It's going to be that line right there, which is line BC. Okay, and why would this be wrong if I say BC with this thing over it is not the correct way to represent the intersection of the 2 planes? Why is that wrong?
Because it's representing a line that just stops.
Right, because BC represents a line segment. And because this thing, if this top thing is just, you're showing it here, but it goes infinitely far, and the one on the side goes infinitely far, so this line BC is going to go infinitely far in both directions. Therefore, it's a line rather than a segment. Okay, one more thing about, I'll let you guys copy that down, and then we got one more thing about 3 dimensions, and then we will have me stop talking, which everybody's going to be excited about. All right, so the final question we got here is, what plane consists of N, P, and Q? So if you draw this box here, which plane has N, P, and Q in it? And if you look, that one would be kind of like the bottom of the box. Right. That's the bottom of the box, is that plane. And what plane consists of J, M, and Q? Okay, that's going to be, it's kind of hard to see, but if you look, it looks like that. This plane here, it goes through J, it goes through M, and it slides sort of down through the box, and it hits Q. It also hits P. It didn't ask us that, but it hits both those. And that's how, again, any 3 points, in this case, J, M, and Q make up a plane. In the top one, N, P, and Q make up a plane. Any 3 points make up a plane no matter what.